This is Algebra 2 with Trig, 8A.2. We're talking about trigonometry and all 6 trig functions. As we've talked about before, theta is a letter from the Greek alphabet. And theta represents an angle value. So that's what that symbol means, theta. Recall that a trig ratio is a ratio of the lengths of two sides of a right triangle with respect to its acute angles. So when we talk about trig ratios, we're talking about sine, cosine, and tangent. The words that we use: opposite, adjacent, and hypotenuse. Those describe the sides of the triangle in relation to the particular acute angle that we're working from. So far, we have studied the sine, the cosine, and the tangent.
Any more people?
So now we're going to talk about 3 new ratios. Cosecant, secant, and cotangent. So sine is going to be related to cosecant, cosine is going to be related to secant, and of course tangent is related to cotangent. Notice that the ones that we know about have an S and a C. They start with S and C. Cosecant and sine also have an S and a C. Unfortunately, the S's don't go together and the cosines don't go together because they both start with C, they both start with S's. But it is, one starts with an S and the other one starts with a C. So what do I mean? What's the advantage? What's the relationship between the two? We know that sine is opposite over hypotenuse. So our new trig ratio, sine starts with an S, cosecant starts with a C. They are related. So they're related by being a reciprocal of each other. So we have hypotenuse over opposite. So just as we did that one, cosine, we know that to be adjacent over hypotenuse. Cosine starts with a C, so it pairs with the S. Cosine and secant. So secant's going to be the reciprocal. Hypotenuse over adjacent. And we know that tangent is the opposite over the adjacent. That's tangent, so cotangent, which is its reciprocal, is going to be adjacent over opposite. So even though it's 3 new trig ratios, they're very much related to our original 3. You just need to know how they're related. And I remember it that our originals have an S and a C in it, and our new ones have a C and an S in it. So the S of one family goes with the C in the other, and the C of this family goes with the S in the other. S and C go together. So what we notice is that they are reciprocals of each other. All right, we're going to evaluate the 6 trig ratios from theta. So if this is our theta, across from the theta is considered the opposite side. Next to the theta is considered the adjacent side, and across from the 90 is considered the hypotenuse. So the trig ratio we can do right now is figure out what opposite over adjacent is. And that's going to be tangent. Tangent of theta is opposite over adjacent. And the cotangent of theta, tangent and cotangent are related. So they're going to be opposite, or actually reciprocals. Opposite would mean that the sign was changed. The signs aren't changing, but the numerator switches with the denominator. So 24 over 7. Now that's the best we can do with this information. But we'll need to come up and figure out what our hypotenuse is going to be. What method do we use to determine the hypotenuse? We can use Pythagorean theorem, and I believe this is actually a Pythagorean triple. Not all right triangles are Pythagorean triples. Pythagorean triple means that all 3 numbers are whole numbers. So 7, 24, and 25. That's what it would be. If you know that, you can figure out the missing side a lot quicker. But if you're not sure, the majority of us would probably have to calculate this out. The hypotenuse squared equals 49 plus 576. When you add the 576 and the 49 together, we get 625. So when you take the square root of that, that's the square root of 625, we get 25. So our missing side is 25. So now we can determine what sine of theta is. The opposite over the hypotenuse is 7 over 25. And of course, the cosine is going to be the adjacent over hypotenuse. But we can write with the other family now. Sine relates with which trig ratio? Cosecant. And that's abbreviated CSC. And they are reciprocals of each other. Cosine is related to what other trig ratio? Secant. And that's the reciprocal of cosine. So there we are. We found our 6 trig ratios. Now we have one for you to try. So you can pause the video and you're going to try to come up with your 6 trig ratios for this triangle with theta being across from 15. So here what we see is the opposite of theta is going to be the 15. Adjacent will be next to the theta, and across from the 90 is the hypotenuse. So the way that this is written right now, we're ready to talk about sine. So sine of theta is going to be 15 over 17. And we can do the cosecant of theta as 17 over 15. But we can't do anything with adjacent because we don't know the adjacent side. So we need to come over to the side and do Pythagorean theorem. 17 squared equals 15 squared plus our unknown, we'll call that y for now, y squared. I believe this is 289, 225, and y squared. When we subtract the 225, we get 64, and we take the square root, and this is also a Pythagorean triple. Doesn't have to be a Pythagorean triple. So now we can do the cosine of theta, which is 8 over 17. The tangent of theta, which is 15 over 8. Opposite over adjacent. We know cosines related to secant, and they are reciprocals of each other. And tangent is related to cotangent, and they are reciprocals of each other. And there we have it. So we flip over now. So here we have theta. Theta is an acute angle of a right triangle. So think of your right triangle, and theta is going to be the acute angle. It really doesn't matter where you put it. I'm going to put it at this angle because if I'm going to work with cosine, and I know cosine is adjacent over hypotenuse, I have a side of 3 and I have a hypotenuse of 8. I assume that my missing side is going to be a little bit longer than 3 because I know that these two sides have to add up to be greater than 8. But anyway, it's just a little approximation thing. We know the cosine of theta is 3/8, so we can draw our figure. We need to know the one more missing side for us to calculate the other side. So to find our missing side, of course, we need to use Pythagorean theorem. Now, let's discuss why we need this side. I kind of jumped to that conclusion already. What we're trying to figure out is what is the cosecant? Well, what does cosecant stand for?
Sine, opposite side.
We know that cosecant is related to sine. So if we can figure out the sine of theta, then I can figure out what the cosecant is. Because one starts with an S, one starts with a C, so they're reciprocals of each other. From theta, I don't have opposite value to calculate the sine for opposite over hypotenuse. So I need to figure out the opposite side so I can do opposite over hypotenuse and then flip it. So the hypotenuse squared equals the leg squared plus leg squared. 8 squared equals 3 squared plus this adjacent side. We can call the adjacent side x. So we have 64, 9, and x squared. When we subtract the 9 across, we get 55. Then we need to take the square root of both sides to figure out what x is by itself, what that opposite side is. So opposite over hypotenuse is going to be square root of 55 over 8. That is the sine. So that makes the cosecant, which is related to the sine, the reciprocal. But unfortunately, we can't do the square root of 55 in the denominator. So we have to rationalize the denominator.
Why can't you do the decimal?
So when we simplify this, we're going to get 8 square root of 55 over 55. We do not want to use a decimal. Notice that you would still have to calculate square root of 55 anyway. And when you put it into the denominator, it's not very difficult to write root 55 over root 55 and connect your 8 root 55 and simplify your pair of radicals. All right, let's try our other one. So we know that theta is an acute angle of a right triangle. We know the sine of theta is 6 over 10. So the opposite over the hypotenuse is 6 over 10. Now this is asking for the cosine. If it was asking for the cosecant, then it would just be 10 over 6. It's asking for the cosine. So we do need to know what the adjacent side is. So again, we're going to have to say hypotenuse squared equals leg squared plus leg squared. That's 100 equals 36 plus x squared. Subtract the 36, and we get 64 equals x squared. That makes x equal the square root of 64, which is 8. Now we're ready to determine what cosine is, which would be adjacent over hypotenuse, 8 over 10, which means the secant would be the reciprocal of that, which is 10 over 8. We could easily figure out what the opposite over adjacent is, which is the tangent, 6 over 8, and the reciprocal of that, which is cotangent, 8 over 6. Since we have sine as 6 over 10, we would know that cosecant would be 10 over 6. So again, we practice finding all the different trig ratios. Last thing to work on here. As we move more into some other trig topics, having a knowledge about a 45-45-90 triangle and a 30-60-90 triangle is going to be very helpful. In a 45-45-90 triangle, we have two legs that are the same length. And there's a pattern that you learned in geometry that tells us that the hypotenuse of a 45-45-90 triangle is root 2 times that leg. So I often like to write it as a hypotenuse equals the leg times root 2. there's only one formula you need to have to work with the 45, 45, 90 triangle. A 30, 60, 90 triangle, because you have two angles that are different, you're going to have two different legs that are different. We're going to have two different formulas. If you know the short leg, whatever the short leg is, the hypotenuse is twice that amount. That is true about every 30, 60, 90 triangle. Across from the 30 is the short leg. So that's why when we talk about our calculators, the sine of 30 is a half, because the opposite over hypotenuse is always 0.5. So the hypotenuse of a 30, 60, 90 triangle is the short leg times 2. People make a mistake and they talk about it as the short leg times root 2 because they're thinking about this one, but they're different. Now the long leg is also related to the short leg. It is the short leg times root 3. So the long leg equals the short leg times root 3. We're going to be using these ratios as we move forward as we talk about the unit circle. But let's practice a tad with those. If we're given this long leg, it's across from the 60, so I know it's the longer side. X is across from the 30, so I know it's the shorter leg. And of course, across from the 90 is the hypotenuse. So I have the 8. I have to use a formula that deals with long, and that would be the long leg equals the short leg times root 3. So I put the 8 in for the long leg, the x in for the short leg, times root 3. Now how do I get the x by itself? I need to divide by root 3, and that gives me x. But again, I have the root 3 in the denominator. We don't want a decimal version of this, so we have to rationalize the denominator. And there's nothing else that can be reduced here, so that's just my value of x. So that is 8 root 3 over 3. So now to find the hypotenuse of a 30, 60, 90 triangle, I'm going to have to use a formula that deals with the hypotenuse. That's the short leg times 2. Well, the hypotenuse is going to be the short leg, which is 8 root 3 over 3, times 2. How do I multiply these two together? Some people say they like to put 2 over 1 and multiply straight across. It's not cross multiplying. There's no equal sign in between. So it's 2 times 8, which is 16. We cannot multiply the radical, so it's just root 3, over 3. And that's the hypotenuse of a 30, 60, 90 triangle, at least of this one. 16 root 3 over 3. And last one, you try to use your formulas about a 45, 45, 90 triangle to calculate what the leg length would be. Pause the video, give that a try, come back and I'll walk you through it. So as we come back and try this out, I notice we have a 45. This would have to mathematically be a 45 to add up to 180. So 45, 45, 90 triangle. we have one formula. We just call it leg because both legs are the same length. It's not a short and a long. The hypotenuse in this case is 6. The leg is x, root 2. To get x by itself, we're going to divide by root 2. That would divide. So we have 6 divided by root 2. We would need to rationalize the denominator, which is 6 root 2 over 2, and we can simplify that to be 3 root 2. That would be our hypotenuse. That's the leg. 3 times root 2. If you multiply that by root 2, you would get 6.